Hey guys, Mr. Brown. Welcome to your first COVID-19 apocalypse lesson on properties of logarithms. Today's lesson is going to cover things like expanding and condensing and evaluating logarithms. So applying properties of logarithms. So first thing, these are the properties we're going to be using today. Take a minute, pause the video, and copy these down in your notes and be able to reference back to them. Now, why these properties work the way they do, I'm going to show with some simple examples here. For our first one, the product property. If you are taking the log of the same base of two numbers that are multiplied together, you can expand that by adding the individual logs together. So, for example, if we look at something like this, log base 2 of 4 times 8. If we do this, and then if we do it this way, I can show that they equal the same thing. So log base 2 of 4 times 8. 4 times 8 is 32. So this is log base 2 of 32. Well, log base 2 of 32 is 2 times 2 is 4 times 2 is 8, 16, 32. It's equal to 5. 2 to the 5th is 32. So that equals 5. If I apply that same strategy here, well, log base 2 of 4 is 2, right? 2 times 2 is 4, so it's 2, plus 2 cubed is 8, so log base 2 there is 3. So, and 2 plus 3 is obviously 5. I can do the same thing with the other two properties as well. Log base 2 of 8 over 4, and log base 2 of 8 minus log 2 of 4. If I do it on this side, this is log base 2 of 2. Well, 2 raised to the first power is 2, so that's 1. Here, 2 cubed is 8, so that is 3 minus 2 squared is 4, so that one's 2. So 3 minus 2 is obviously equal to 1. The power property, sometimes we call this plugging because it makes a p log the way that we write it. I can do the same thing. I'm going to use slightly different numbers here. So log base 2 of 4 cubed and 3 log base 2 of 4. If I look at this side, 4 cubed is 64. 2 to the 6th is 64, so log base 2 of 64 is 6. If I look at this side, it's 3 times log base 2 of 4. Well, 2 squared is 4, so it's 3 times 2. 3 times 2 is equal to 6. All right, so what you're actually going to be doing with this. First off, we're expressing logs in terms of their bases, of some of their factors. So express natural log of 96 in terms of natural log 2 and natural log 3. What I'm going to do to start this is factor out 96. So I've got it factored all the way where it's the prime factorization. These are all prime numbers. It's also all in 2s and 3s, which is what I want. So what I'm showing here is that the number 96 is equal to 1, 2, 3, 4, 5 2s, so 2 to the 5th power times 3. That means that the natural log of 96 is equal to natural log of 2 to the 5th times 3. Now I'm going to expand this using those properties in the previous slide. I can split up natural log of 2 and natural log of 3 and make this natural log of 2 to the 5th plus natural log of 3. And now the last thing, this isn't technically in terms of natural log 2 yet, it's in terms of natural log 2 to the 5th, which is natural log 32. So I'm going to plug this by moving the 5 out in front for my final answer. Like that. you want to pause here and try this one on your own, feel free. Otherwise, we'll take a look at it. So log 32 and 9 in terms of 2 and 3 again. 32, that's equal to 2 to the 5th. And 9 is equal to 3 squared. So now I've got a base of 2 and a base of 3. That means that this is the same as log of 2 to the 5th over 3 squared. Now I'm going to expand this again. So the first property, the quotient property, I can split these two, the top and bottom of the fraction, by subtracting them. So log 2 to the 5th minus log 3 squared. And then I can finish this by plugging them, so it's log 2 and log 3, not log 2 to the 5th and log 3 squared. So the exponent moves in front, and it's 5 log 2, and then the exponent moves in front there, minus 2 log 3. Okay. All right, now using these properties to evaluate. This is something that I'm going to kind of force myself to use these properties to evaluate. It's not 100% necessary, but it's just reinforcing and more practice with those properties to prepare for the test. Cubed root of 32. At this point, we should be able to recognize that this has an exponent form of 32 to the 1/3 power. Not necessary to show this part of the work. You could certainly just know this and plug it right away. But it's probably at this point better to show that. All right, so if I plug that, now I've got something that's kind of a nice number to be able to evaluate, at least nice for logs. 2 to the 5th is equal to 32, so log base 2 of 32 is 5. So this is equal to 1/3 times 5, which is 5/3. All right. This one's a little bit of a throwback to what we did, when we still had like normal school, and we covered some of the properties where we can cancel natural log and e. So you guys have already actually done this one before, but we could start it by just crossing out the natural log and the e, and now it's 3 times 4 minus 2 times 2. That's 12 minus 4, which is 8. All right, so at this time, it would be a good idea if you wanted to pause the video for a while, take a look at the homework. I'm only going to remind us of this the first couple of lessons, but I'm not going to be checking this homework. This is really extra practice. The homework quiz is how your progress in the homework and your participation is going to be recorded. So it's really up to you. If you get a few of these done and you feel like, yep, I got this, move on to the next. You don't have to do every single one of these. But it's really just to make sure you have enough practice should you need it. All right, so the rest of the lesson, we're just talking expanding and condensing. Now, I want to go back to that slide where we had the properties. And I want to show, if you're wondering, like, what does it mean to be condensed, what does it mean to be expanded? If you look at the two sides of these equations, this is the smaller side. This is what we mean when we say it's condensed. This side, where it's wider, this is the expanded side. For those, when it comes to condensing and expanding, it truly doesn't matter what order you do things in, but I find it best if I'm expanding to do these properties first and then plug last. So I do them in this order, going down. If I'm condensing, I start by unplugging things and then apply these properties second. So you can add that to your notes if you want. A lot of students find that helpful. I found over the years. All right, where were we? We were going to expand this. So I'm going to start out by applying my product and quotient. Now everything's positive here, so it's all going to be plus. Positives are multiplying results in positives, dividing results in negatives, is how this works. Okay, so natural log, this is going to be natural log of 4 plus natural log of m cubed plus natural log of n to the 5th. So I expanded it using the product property. The last step is going to be to plug the exponents. Natural log 4, 3 natural log m, 5 natural log n. And there's your final answer. All right, something like this. This has got a few tricks in it. We just sort of went from like 30 to 60 in one example. So first thing I'm going to do again is to expand this using the product and the quotient rules. One thing to note, to split things up, they have to be factors. This doesn't have a common factor to factor out of it, so I can't split up the 2x and the minus 3. I'll show you what this looks like in a second. However, the 3 and the 4th root of x, these things are multiplied together, so these two are going to split up. First thing, this one is positive. Whatever's on top stays positive, so it is log of 2x minus 3 in parentheses because I can't split this up by factoring, so it's got to be one quantity with the logarithm. Now these two are going to be separate, and they're both going to be negative. The 3 is on the bottom, so it's going to be minus log 3. The 4th root of x is also on the bottom. So that is also going to be minus log of x. And I'm going to make it to the 1/4 power so I can plug it next. Very common mistake with these that students make is they think it's 3 plus this because they are multiplying. However, that would be true if I put parentheses around everything. So then when I distribute the negative in, this becomes negative, this becomes it's just like a negative exponent rule. A negative exponent makes something go to the bottom of a fraction. Same thing here. If it's from the bottom of a fraction, it's going to be a negative log. All right, so then last thing would be to plug it. So this 1/4 would move out in front of the log x. All right, so then condensing. Condensing, I'm going to do the opposite. I'm going to start by unplugging things, and then I'm going to apply the product and quotient properties. So this 1/2 is going to move over here. The 3 is going to move here. So this is now going to be log x. Log base 4 of x to the 1/2. Log base 4 of x minus 2 cubed. Then I'm going to use the quotient property to put it all together. So log 4. Anything positive is going to stay on top of the fraction. Anything negative is going to move to the bottom. So this is an x to the 1/2 on top. Yes, you could write it as the square root of x. I don't really care. Log base 4 of, and then the x minus 2 cubed on the bottom. Another common mistake students make with this is they make it log of this over log of this. There should only be one log. It is log base 4 of the entire quantity, not log base 4 of this divided by log base 4 of this. Those are two different things. All right, condensing this one. Really, it's the same thing. If you want to pause and try it out and check, great idea for right now. The 5 is going to move over here. The 6 is going to move here. And then we're going to put it all together. Not log, natural log. I guess I can make it log base e. X plus 1 to the 5th times x to the 6th. No, we don't have to expand this using Pascal's triangle and then distribute the x to the 6th. And no, you can't distribute the x to the 6th into here without first expanding that using Pascal's triangle or binomial theorem or whatever. All right, so very last thing, change of base formula. This is a formula that you would use using a calculator, basically. If So if your calculator can't enter what this is, like exactly how it looks, this is how you're going to split it up. It's going to be log of this part, the x, over log of the base b. And if you're trying to remember how that works, the x is sort of above the b, right? And so the x is on top and the b is on the bottom. That's how I used to remember it. Okay, so something like this. I'm going to show this using the log base function in the calculator, and then I'm going to show it without it as well, so you've got two options. But really, at this point, if you're comfortable, this is the last thing. If you know how to do this in your calculator, you're good. Okay. So let's get on my calculator. We're doing log base 6 of 4, so ask yourself, what class am I in? I'm in math class. So I'm going to use the math button. In the math menu, it is option A, so you can either click up a couple of times to go from the bottom of the list, or click down a bunch of times. Doesn't really matter. Select log base, hit enter, and then now it looks just like that, and you just fill in the blanks. So it was 6. And 4, hit enter, and it should be about 0.77. All right, so the next example, the second to last example, I'm going to show this without using the log base formula, or the log base function on the calculator. And that is actually, if you remember how to do it, that is actually a lot faster. This is how I usually do it, just because it's fewer clicks. Where's my cursor? So we can go log of 8, the bigger number, end parenthesis, or this is not going to work, divided by log of 1/3. And it would look like that. And that is actually a lot more efficient to do it that way. And if you don't have a calculator with the option, it's really the only thing you can do. So yeah, negative 1.89. I will get better at tracking my cursor while I'm doing these, so these videos should get a little bit more efficient. All right, so there's your homework. Again, this is really practice to make sure that you have enough practice to prepare yourself adequately for the test. I'm not going to have you hand this in. I'm going to check that you took the 5-question homework quiz. So use this as you see